So now we will be solving 7th question from year year 2022 ODE. So in order to solve this problem, like this is initial value problem by Laplace transform. Given h of t is this, y of 0, y at x equals to 0, y at x equals to 0 given. So like this is Laplace transform, and we have seen previously that Laplace transform is asked every year. So one need to be thorough with respect to all the definitions, all the formulas and all in order to solve this problem. So what we will do is that we will write the equation d2y upon dt square minus 3 dy by dt plus 2y h of t. So taking Laplace transform both sides, we get, if we take Laplace transform, then it will become Laplace transform p square Laplace transform y minus p y of 0 minus y double dash 0 minus 3 Laplace transform of y p minus y of 0. Here it would be y dash y of 0 y of 0, fine. Then it will become Laplace transform of y, then become Laplace transform of h of t, fine. And now we will see that since y of 0 is 0, y at x equals to 0 is 0, y dash 0 is 0, y of 0 is 0. So it will become p square Laplace transform of y minus 3p Laplace transform of y plus 2 times Laplace transform of y Laplace transform of h of t. Fine. We segregate it. Laplace transform of y p square minus 3p plus 2. Now we take Laplace transform of RHS side. Laplace transform of RHS side would be like from definition, from the standard definition, 0 to infinite, 0 to 4 basically, e की power minus pt. 0 to 4 is 2 dt, 4 to infinite is e की power minus pt to 0. This entire term will become 0 since the terms are being multiplied with 0. So while solving this, we will get that 2 e की power 2 by p, yes, 2 by p, 1 minus 4 e की power 4p, I guess. Yeah, I am writing directly. E की power minus 4p. Yeah, it's fine. Now we will be sending p square minus 3p plus 2. So Laplace transform of 2 by p, like we will factorize this, p minus 1 p minus 2 minus 2 by e power minus 4p p upon p minus 1 p minus 2. I think it's correct. Now taking inverse Laplace transform, Laplace transform both sides. So it will become y L inverse 2 by 1 by, this is Laplace inverse p minus 1 p minus 2, sorry, then will come minus 2 Laplace inverse of e की power minus 4p p minus 1 p minus 2 is fine. So we factorize it 2L inverse. So I have already discussed how we factorize such kind of thing in the previous video, that is ODE 2023. Similar question was asked, so I had factorized through tricks there. You may watch that video to get grasp of how we do that. So if you do if you put minus 1, then it will become 0 1 minus 1. It will go 1 by 2 p minus 2. Fine, I think we will be doing later. Similarly, we can do this also for this also. You may watch my previous video, like ODE 2023. I have discussed like how we factorize these things quickly using trick. Like it will be minus 4p 2p minus e square minus 4 e raised to the power minus 4p. Then it will become p minus 1 e raised to the minus 4p. Then it will become 2. I think it was 2 p minus 2. I think we are correct. Yeah, we have not any kind of blunders here. Fine, like what we do is that like just multiply it here. Then Laplace inverse of 1 by p becomes 1 by 1 minus 2. It will become e की power t. Then it will become e की power 2t. Yeah, we are correct. Like multiplying L2 into both each terms, that will become e की power minus 4p p minus e raised to power minus 4p. It will become 2 e की power divided by p minus 1. Then it will become e minus 4p e minus 2. Yeah, like how we solve these terms, like for that we need to apply shifting theorem. So I'm just writing this what shifting theorem is, like in order to make your understanding easy. So if Laplace transform of f of p is f of t, then Laplace transform of e of minus ap f of p is nothing but f of t minus a, where t is greater than 0 when t is less than a. So there will be two cases when when t would be greater than 4. Like if we compare this term with this, so like say um, say t is less than 4, then the entire term will be 0. This entire term will be 0. So 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 for t is equals to -4, y will become simply 1 minus 2 e raised to the power t, e raised to the power 2t. If t is greater than 4, then y is equals to 1 minus e to the power t, e to the power 2t. I think there will be 2. Fine. And in order to solve this, what we'll be doing that solving this part, we are just putting we are using this formula only, like nothing else. So we know that 1 by p is 1. So even if we put t minus 4, it's make no differences. There is no any variable term involved. So for this minus 2 e, for Laplace transform of 1 upon 1 by p minus 1 upon p minus 1 would be e raised to the power t. So doing the Laplace shifting this t minus 1, then it will become t minus 4. Then it will become similarly, it will become e 2t minus 4. So this would be our final solution. Just the thing that we need to know this shifting formula. It's very frequently used, so I would say that take a very serious note, like where you can utilize this formula and you solve your problems. So now moving ahead. So again we have this type of question was asked previously, like in 2023, like we are solving in a backward direction. So first we solved 2023, then we are solving 2022. So similar questions was asked in 2023 also. So we can predict that what kind of question being asked. So the pattern or theme of the question is almost same, but only the some general alteration is done. Like the theme is some many times repeated in UPSC in maths paper too, just like as it happens in GS papers and prelims paper. So again, it is a problem of to find the general and singular solution of differential equation, where P is dy by dx, geometric relation between general solution and singular solution. Like we have seen in 2023 also, general solution and singular solution were asked. So we'll be solving this. The given equation is x square minus a square t square minus 2xyp plus y square a square is equals to 0. And now what we'll be doing that, see there is if you will observe it clearly, and we will find that something square terms is there. So you see x square y square 2 minus 2x xp. So the entire terms become square. So x p minus y square minus a square p square. So if your observation is very kind of accurate, it will be, you will be able to see things which will make your life easier. So first try to observe the problem, like what it says, what new thing, what new insight we can draw from the question. It will actually reduce your manipulation and time also. We take xp minus y square is equals to a square p square minus a square. If we take under root both side, xp minus y plus minus, mind it, there will be plus minus both. Many times we tend to forget the negative sign here. See, it is going to get converted in claret form. xp minus plus minus a square p square minus a square. So this is claret form. Claret's form. So general solution of 1 is given by y is equals to cx plus minus a square p square c square minus a square, where c is where c is any constant. Fine. So in order to find singular solution, what you need to do is find c discriminant. And this is a property which you can use, is that like in the claret form, c discriminant and p discriminant both are same. So we can directly go from the first equation itself, or even we can go from this equation also. This equation and this equation discriminant will yield same result because it is in claret form. Discriminant. What we do is that, like, take y minus cx in RHX, square it, then it will become a square minus. Why we did so? Like, by doing so, this radical term, the square root terms will be gone. Y square c square x square minus 2 cyx, fine, a square c square minus a square. And we try to make c square terms together. C square x square minus a square minus 2cyx 2cyx 0. Discriminant b square minus 4ac. Discriminant b would be 4 y square x square minus b 4a x square minus a square. C would be y square. We are correct now. Yeah. Yeah, there will be a square terms also. Yeah. Fine. So just we simplify this entire equation. 4y square minus x square minus 4y square x square minus 4 x square y square x square a square a minus a raised to the power 4 minus a square y square. This term will get cancelled. The entire equation will get reduced to 4 a square terms common, x square minus a square minus y square is equal to 0. Since this is a constant term, it can be made 0. It can be eliminated. It can be 0. It can be eliminated both sides. Since it is since 4 square is non-zero, so it becomes something like that. A x square minus y square is equals to e square. This is the singular solution. This is the singular solution. Singular solution which also satisfies the given equation, which also satisfies the given equation 1. Say this is B. Say this was A. This was our original equation. Say this is 1. Then we have got original solution. Singular solution. We have got singular solution. We have got general solution. Now what we need to do is that also show the geometric relation between general solution and singular solution. So we know that, like by the definition, singular solution is nothing but the envelope of general solution. So this equation, which is hyperbola, so basically it is geometrical relation we need to find. Geometrical relation. So if we draw this hyperbola, it will be enveloping our general solution. Like how I can explain it, like there is a circle, there is a straight line which is a tangent to this circle. We can find through the general equation of circle that a straight line can always be found which can be tangent to this circle. So we will be saying that this straight line is enveloping the circle. So similarly, the singular solution, equation 3, equation B is envelope of equation A, that is general solution. This is singular solution. So that we need to show. Fine. So this is a frequently asked question. So you need to be aware, like how we need to find, how we find general solution and singular solution, and what is the relation, how they are related, general solution and singular solution. So moving ahead. So it's a standard kind of equation, like 3x square, 3x plus 2, and something in RSS. You will. This is a standard format. Like whenever something like this kind of comes into picture, what we do is that we assume this term, the linear term, as something as 3x plus 2 as e raised to the power z. This is a standard format. This is just a standard rule to solve such problem, and it makes our life easier. So whenever when you will differentiate it, when you will try to manipulate this thing, you will get that d2 y upon, you will when you will take this and manipulate it, you will find that 3x plus 2y becomes dy by dx becomes 3 upon this term a d by dz, since we have taken another another variable z. Similarly, 3x plus 2y whole square becomes, suppose we say this term as d is equals to d by dz. So this will become 9 d minus 1, where d is d by dz. How we can write it generally? We can in general terms we can write it as ax plus b square is nothing but d y upon dx square is a square, basically a coefficient of x, a square d minus 1. This can be extended to up to any order of differentiation. So we substitute this in original equation and our task will be simplified. So what we'll be doing is that 9 substituting in original equation, substituting. So it will become 9 d minus 1 plus 5 into 3d minus 3d, I guess 3d is equals to now we need to replace x in terms of z. So from here we can say that x is nothing but e raised to the power z minus 2 by 3 e raised to the power z minus 2 by 3 x square plus x e to the power z minus 2 x square plus 1. Fine. So this becomes a typical ODE equation where we'll be finding complementary solutions, complementary function, and then we'll be finding particular solution. So in order to find complementary function, what we do is that we make this equation homogeneous. So 9d d minus 1 15d minus 3d. Oh, sorry, this will not be d. So basically there is no differentiation here, so it will become it will be just y. So this entire will be multiplied by y because there will be y d. This will become 3 dy by dz. So something like this. Fine. Then make it into 0. So we get as 9d square minus 9d 60 minus 3. I think we are correct. Yeah. So we have to 15 minus 3 9d square minus 9d plus 60 minus 3. So we have to solve this. What we can do is that 27 9d square plus 9d minus 3d minus 3. So factor with 9d d plus 1 minus 3 minus 3 d plus 1 is equals to 0. So what it becomes is that 9d minus 3 d plus 1 is equals to 0. Yeah, fine. So solutions are d is equals to 1 by 3, d is equals to minus 1. So the complementary solution YC is complementary function we are finding. Complementary solution is nothing but y is equals to c1 e की power 3z. Mind it, like we are not dealing with x here, we are dealing with z. c2 e raised to the power minus z I think we are correct. Now finding particular solution. Finding particular solution. Finding particular solution. Yp is nothing but we'll be simplifying this RHS term. E2z 4 minus by 9 minus 2 divide by the entire here equation was this simplified one. 90 square 6d minus 3, 90 square plus 6d minus 3. Fine. So we'll be manipulating, solving, simplifying this. It become 9. Then E2z plus 4 minus 4ez 3ez minus 6 plus 9 E2z then become minus ez 9 13 7 here. Then we will find in the particular solution. We'll be bringing this 90 square 6d minus 3 yp. So segregating the terms, 1 by 9 E2z 90 square minus plus 6d minus 3 minus ez 90 square 60 minus 3 7 square 60 plus 3. Yeah. So what we need to do that we just plug E2z 36 436 12 minus 3 ez 9 6 minus 3 0, since is nothing but e raised to the power 0 z. Yp becomes 1 by 9 e raised to the power 2z, then 9 45 z 15 12 7 by 3. So y total would be y complete solution will be nothing but y complementary plus y particular. The y complementary is nothing but C1 e की power z by 3 plus C2 e raised to the power minus 1 minus z. Fine. And then it will become e equal to z by 45 minus ez by 12 minus 7 by 3. So what we can now we have to change z into x. So z is nothing but, we know that, like what we have substituted at the very beginning was 3x plus 2. 3x plus 2 is nothing but e raised to the power z. So this will become, substituting C1 e raised to the power, so this will become this will become 3x plus 2 raised to the power 1 by 3. C2, this will become 3x plus 2 minus 1 by 9, 3x plus 2 whole square by 45 minus 3x plus 2 12 minus 7 by 3. So this is the solution that we need to find. Hence this is the answer. That's all. Thank you all.